In this video, we will look at how to recognize if there is a proportional relationship when you're given a graph. So let's take two examples of proportional relationships and plot the graphs for these relationships. Let's look at the first one. We have a table here where we have time versus distance. Now, time would be our independent variable, so that would be on the x-axis. So let's just write here time in hours. And of course, we're going to put 0 here, and let's just say this is 1, 2, 3, 4, 5, 6. And then the distance in kilometers would be on the y-axis. That's our dependent variable. So this is distance in kilometers. Now let's start plotting the points. So we have 0, 0, which is here. When the time is 1 hour, the distance is, oh, I forgot to label put the intervals on the y-axis. So since it seems to be going up by 40, let's just go up by 40 even on our y-axis. So this is 40, 80, 120, 160. I have to write really small here. And did I miss anything? 40, 80, 120, 160, 200, and this would be 240. So we have 0, 0, and then for 1 hour we go a distance of 40 kilometers, and for 2 hours it is 80 kilometers, and 3 hours it's 120 kilometers, and so on and so forth. Now when we actually join these points that we have plotted, and let me do my best effort at joining these points, you'll notice that, okay, this is what it looks like. Okay, this is not bad, and I'm going to draw an arrow to show that it keeps going on. So this is our first example. Let's look at our second example. It says that there is a cran-apple juice, and that's made by mixing cranberry juice and apple juice in the ratio 2 to 5. Now, since both of these are ingredients, either of them can be on the x and the y axis. So let's just have the cranberry juice. So say cranberry juice, and the, let's say, cups. And for the apple juice would be on the y-axis, and it doesn't really matter if you actually interchange it, since there is no definite independent and dependent variable here. And then let's start plotting it. So here you would have 0. There's lots of space here, so I'm just going to write 1, 2, 3, 4, 5, 6. And since this side goes up by 5, I'm actually just going to go up by 5s here. So 5, 10, 15, 20. So let's plot the points here. When we have 2 cups of cranberry juice, we have 5 cups of apple juice. So let me pick a color. When we have 2 cups of cranberry juice, we have 5 cups of apple juice. So that's 1 point. When we have 4 cups of cranberry juice, you need 10 cups of apple juice. And when we have 6 cups of cranberry juice, you'll need 15 cups of apple juice. And when you don't take any cranberry juice, you wouldn't take any apple juice either. Now let's join these points. I'll do my best attempt at joining these points neatly. There you go. So what is it that we notice about these two graphs? Pause the video here, look at these two graphs, and write down a few things that you notice about these two graphs. Things that are common and things that are different between these two graphs. So there are lots of things that are different between these two graphs. Their labels are different, their intervals are different. If we had put a title here, the title would be quite different because it's describing different situations. But two things that are common to both these graphs, the first thing is that both the graphs are a line. So there is a line here and there is a line here. I know this kind of doesn't look like a line, but if I had used a ruler, you would have seen that this is a line. So the first thing is that the graph is a line. What's the second thing that you've noticed? The second thing is that the line always passes through the origin, always passes through 0, 0, which kind of makes sense because if you don't spend any time traveling, you actually don't go any distance. Or if you haven't taken any cranberry juice, there is no need to take any apple juice because you can't quite make a cran apple juice. So let me write the second thing here. It passes through the origin. Now let's look at two relationships and their graphs where the relationship is not proportional. Let's look at the first example. We can clearly see that this relationship is not proportional because here we have a ratio of 1 to 5 and here we have a ratio of 2 to 7, and those two ratios are not the same. Now let's start plotting these. So let's make sure we write 0 here, and we could write here 1, 2, 3, 4, 5. And on this side, let's change the color. So 1, 2, 3, 4, 5, 6, 7. So this is 0, 3, 0 on the x-axis and 3 on the y-axis. So this is the first point. The second point is 1, 5. And the third point is 2, 7. Now when we join these, this is a line, but it does not pass through the origin. Let's look at the second example. Again, we can see it's not proportional because here we have a row of 1 to 1, while the third row is 2 to 4. In fact, the relationship is that the y is the square of x, and we can write that as y equal x square. So again, let's start with the 0 here and write 1, 2, 3, 4. Again, one of the things that I like to do is put tick marks here, which I haven't quite followed in my earlier graphs. Now let's start plotting the points. So we have 0, 0. Okay, so it passes through the origin. Then we have 1, 1. Then 2, 4. And then 3, 9. There is no way I can join these points using a straight line. In fact, the graph would kind of look like this. This is a graph of what is called a quadratic relationship. So these are examples of relationships that are not proportional, and you can see in one case it goes through the origin but it's not a line. In the other case it's a line but it doesn't go through the origin. To recap, two things have to be true for a graph to represent a proportional relationship. First, the graph has to be a line, and second, the line should pass through the origin. Now let's analyze these four graphs and check if they represent a proportional relationship. Let's look at the first graph here. So, yep, it's a line. So it's a linear relationship, but it does not pass through the origin. That means, nope, it's not a proportional relationship. Let's look at the second one here. It's not a line. It does pass through the origin, but it's not a line, so it's not a proportional relationship again. Let's look at the next one. It's not a line and it does not pass through the origin, and obviously it's not a proportional relationship. And the last one, yes, it is a line, so it's a linear relationship. It passes through the origin, so it is indeed a proportional relationship because it is a line and it passes through the origin.